Hey guys, today we are going to discuss a very simple yet important topic of binary classification versus multi-class classification. So we are going to look at the definition, some examples, classifiers that can be used for either of the cases and how to evaluate them. As a bonus, we are going to look at how inherently binary classifiers are going to be extended for multi-class, okay? And then a very interesting case of one class classifier. So please watch out for this extension of binary to multi-class classification as well as this one class classification. So as if you have a binary classification problem, number of classes are 2. So if you have an unknown instance, okay, which is measured in terms of these two independent variables x1 and x2, this needs to be assigned to either of these two classes, either this here or this tortoise. Okay, as the number of classes are 2, you call this as binary classification or binomial classification. Some other examples quickly are identifying an email as a spam email or a normal email, 2 classes again. Identifying an image as either a cat's image or a dog's image, 2 classes. Predicting whether a customer will default on loan or not, predicting if the employee will leave the organization or not. This is also called as attrition problem. And for the Titanic shipwreck problem, whether the passenger will survive or not. Okay. And all classifiers can do binary classification. However, there are some classifiers which are inherently binary classifiers. So this is a key concept. Okay. So means that their theory was designed assuming that there are only 2 classes. 3 such examples are perceptrons, support vector classifiers, and logistic regression. Now let's see how do we classify or how do we evaluate a binary classifier. A tool that we use is called as the splitting between training and testing set. Okay, so we have this entire data set available, okay, where you have these independent variables which we represented as a vector. So this is actually a collection of independent variables, and let's say there are 100 observations in this data set. Okay, this is a label data. So you have the classes spam and normal. What you do is, first you break them in 2 parts. One part you call it as training set, another you call it as testing set. So maybe you have 70 emails over here and 30 emails over here. So the total is again 100, and they are non-overlapping and they are randomly selected. So you see it is not x1 to x70, but it is x1, x3, x10, like that. Second step, you take a model and train the model using this training data. Okay, and then when you want to evaluate this model's performance, you basically use this model on the testing data set. Now what you get is you already had this actual levels over here, okay, actual class, and now you have already also got this predicted class. And what you want is actually, in most of the cases, or actually in all cases, this actual class to be equal to the predicted class. Okay, this is formally understood using confusion matrix. Okay, so here what we do is, first we calculate number of emails in the test set which were actually spam, and your model predicted it as spam. So we write the count over here. Then we find out that actually which were spam and it was predicted as normal. So I write the count over here. Similarly, I write the count of actual normal, predicted spam, actual normal, predicted normal. Okay. So these are my 4 exhaustive cases, and if this column is my total, all the 30 emails that were in my testing data set, that count should come over here. Okay. And if you look at the row wise sum, this will give you actual number of spams. If you look at this row wise sum, this will give you actual number of normals. And these were your predicted. So this column total will give you total number of cases predicted as spam and total number of cases predicted as normal. Now you might be wondering what these 2-letter things are doing. So TP is true positive, FN is false negative, FP is false positive, and TN is true negative. That's fine. But how this comes? So this second letter, okay, this comes from the predicted part, okay. And for any classification problem, binary classification problem, you take one class as the positive class. So here you take the spam class as the positive class, okay. So wherever you are predicting it as the spam class or the positive class, you are making the second letter as P. Similarly, when you are predicting it as normal, you are making it as N. Now, what you are going to see is that whether the prediction was correct or not. If the prediction was corrected, like here, you will tell it as true positive, and here you will call it as true negative, and here, these two cases, as it was not correct, you will call it as false positive and false negative. So, what do you want? You want this true positive to go up, you want this true negative to go up, and you also want this false positive to go down and this false negative to go down. One simple numerical measure which combines all these objectives is called as classification accuracy. So which is a ratio of true positive plus true negative by all observations. Okay. So if this true positive and true negative was 27, then classification accuracy of such a system was 90%. So it will always have a value between 0 to 1, and closer the value to 1 it is, the better your system's performance is. Okay. So you can also understand that if I say my classification accuracy is 0.9, my misclassification is 0.1 or 10%. Okay. So when we calculate this misclassification of 10%, you do understand that I treat false positive and false negative in a different, in a similar way. We treat that as if, the cost associated with them is same. Okay. So some people have some reservation with that. So for that, they design some more methods. So some methods are called as precision. So precision is a ratio of true positive by total number of predictions as positive. So what is total number of cases as positive? So this column total, true positive by this ratio. So this you call as precision. Meaning is how precisely you are telling an email to be spam. Okay. And there is something called as recall. So which is like out of actual 100 or 10 spam emails, how many you could identify as spam. Okay. So here it is again the numerator is same in both the cases, true positive. The denominator in this case is total number of positive cases, that is the actual number of spams. Okay. All right. So, and again, some people said that for some problems we might want high precision, some problem we might want high recall. But what happens if I want both of them as high? So you can use an average measure. So F1 score just does that, which is a harmonic mean of precision and recall. Okay. So now you might question that, all right, some people may ask that, but is it really practical? So let's look at some cases. Okay. So in case of spam detection, if you look at these two cases, false positive is that the email was a normal email and you predicted it as spam. So maybe you are receiving an email from income tax. Maybe you are getting a job letter. Maybe you are getting an interview call letter from one of the top institutes. That has landed in your spam box and you have ignored it. Huge consequences. If it is a false negative, so it was a spam but it is in your normal email box, it is okay. You can manually delete it. Okay. So here cost of false positive is more. So in this case, you want a system with high precision. Now let's look at another case where you want to detect a person as a threat or a suspicious person, okay, or activity is suspicious. So here if you look at false positive, when you say that being suspicious is the positive case, then he is a normal person and you have predicted him as a suspicious one. So you will ask, hold him for additional interrogation, which is kind of okay. That person will be irritated, but it is okay. Okay. However, think of the false negative. That person was suspicious, but you have let him go. So he can go in some restricted place, maybe a museum, maybe an airport, maybe a public place, and can involve in very dangerous activity. So here the cost of false negative is more. So then you want a high recall system. Okay. Both precision and recall will also have value between 0 to 1. Now, if you take a case like detection of cancer, where both false positive and both false negative has quite a lot of consequences, you will go for a score like F1 score. Okay. Please note, recall is also called as sensitivity, and there is also another measure called as specificity, which is nothing but recall for the negative class. Okay. Now, let's look at multi-class classification. So, instead of 2 classes, here we have 3 classes coming. Okay. So, it is not only 3 classes, you can have more classes, and also the task is if you have an unlabeled data, you have to assign it to either of these 3 classes. Okay. So, some examples are identifying sentiment of a piece of text as positive, negative or neutral, predicting whether a particular day will be sunny, rainy or snowy, identifying whether a patient has flu, viral fever or malaria, or identifying whether a movie will be a box office hit, critical success or a flop. Another example is your MNIST data set, where you have a handwritten digit like this maybe, and you are using your classifier to predict which digit it is. So there are 10 classes. It is a 10 class classification problem. Some classifiers which can naturally do multi-class classification are KNN, Naive Bayes, decision tree, etc. Okay. Now let's look at how we can extend the classifiers which are inherently binary classifier to multi-class classification. So there are 2 schemes for them. The first scheme is called as one versus rest. So let's understand this with an example. So let's say we have a data set like this. Okay. So here also, this x1 is the collection of independent variables, and there are 3 classes, red, green and blue. So you know that you have some classifiers which can do a binary classification. So the trick is convert this to a binary classification problem. Maybe not one binary classification problem, but binary classification problem, but multiple binary classification problem. What we do is we convert this into 3 binary classification problem. So in one case we are finding out red not red, here we are finding out green not green, and here we are finding out blue not. So we train each one of them, okay, and we get 3 models out of them. And now when we have an unknown instance, okay, so we are assuming that these are all classifiers which give probabilities as output. So basically, the red classifier will give output like P1 and P2, okay. So for each testing data, it will give an output like P1, P2. P1 will be probability of the red class and P2 will be the probability of not red class, which can be extended for your green class and blue class as well. Now you have an unknown instance, okay, and if you have used all of your 3 models, let's say your class red has given a probability of 0.6, class green has given a probability of 0.58 and blue has given probability of 0.43 or 0.32, then we'll pick this classifier. Okay, so this is called one versus rest, because you are taking one case and then rest of the cases you are merging and saying not red, not green, not blue that way. So to generalize, if you have n classes, you will need n classifiers, and each actually trains on full training data. Alright, now let's look at the other scheme. So this is called as one versus one. Let's again understand with the same example. So we have the same data available. Now what we do is we convert it still to binary classification, but not in that way. How do we do it? Out of these three classes, we pick two of them at one time, okay? And we build a model for each one of them. So basically, we can pick, three C2 combinations, right? As there are three classes, okay? So 3C2 turns out to be 3, right? So there are three classifiers now, red, green, blue, and green, blue. And I build three models. When I have an unknown instance now, let's say my red blue classifier gives the probability of the class as red, the red blue gives us blue, the green blue gives us blue. So as this has the majority vote, you call the prediction as of blue class. Okay. So the tie can be broken easily. You can pick any one of them, or you can go and look at the probability and do something like that. Okay. So these are two main cases. Now let's look at the confusion matrix, okay, for multi-class classification. But before that, you must realize that number of classifiers in this case is n into n minus 1 by 2, and none of the classifier actually trains on the full data. Coming to the confusion matrix, so if you have three classes, your confusion matrix will be 3 by 3. If you have k classes, your confusion matrix will be k into k. How do you find the classification accuracy? So you just look at the entries at the principal diagonal, okay? You sum them up and sum of that with the ratio of total number of observation gives you the classification accuracy. But what about precision and recall, right? So for precision and recall, let's look at only red class. So here, precision, you want to look at how many of the predictions for red were correct. So how many you predicted as red? 20 plus 5 plus 2. Out of them, how many were correct? 20. So your precision of red class is 20 by 27. Similarly, what about recall? You had actually 26 red classes. How many of them you actually found out? You found 20. So recall is 20 by 26. Okay. So please understand over here that for each of the classes, you will have separate precisions and recall. So classification accuracy is a characteristic of the entire confusion metric, whereas precision and recall are class specific characteristics. Okay, so this is something I wanted you to pay attention to. Now let's move to one class classification. So this is a very interesting case. Okay, so let's start with an example. Let's say you want to find transactions that are fraudulent. So that can be credit card transactions, bank transactions. And you can understand that the number of frauds compared to normal transactions are very less. Okay, so maybe 0.01%, right? And even if there are some example of fraud class, so you know that some cases there were fraud, they're caused by very different reason. So, you can think that, okay, what we are talking about over here is a binary classification. So you have a normal class and you have a fraud class. Okay. So when you, assume something like this, you actually think that you can identify patterns of normal class, and you can also identify patterns of this abnormal class or fraud class. But the problem is that there are very less examples. That is one problem. And also there is no distinct patterns. Okay. So you can think something like this. So these are actually your normal class. Okay. Normal transactions, and these are your fraud transactions. These are also your fraud, and these are also your fraud. And then there can also be some fraud over here. Okay. So there is no distinct pattern. However, there is a distinct pattern of the normal class. So here you forget about the other class and you try to model this class. Okay, you try to model this class, and basically if there is an unknown observation, you try to find out what is the probability that this belongs to this normal class. If the probability is very small, you call it as abnormal. or as your fraud class. Okay, so you are training always on your one class data. So, for your knowledge, this method is often used in outlier detection, anomaly detection, or novelty detection. Okay, so these are some terms used very well in literature, and the one from the normal class is often called as inlier. So these points are inliers, and these are all as outliers. Some algorithms which can be used for one class classification are one class as SVM, and some variants of expected maximization. Both of these which are covered in our previous lectures. So I hope I could give you something insightful. Okay, so if you have found something helpful from the video, please like and subscribe to our channel. Please give your questions on the comment section, and we will try or give our best to answer those questions. Thank you so much once again.